ChatGPT reads more text in training than you could in 10,000 lifetimes, but it still can't stack blocks. Here's why. Let's start with the core idea behind these massive models: prediction. Imagine that any sequence of words can be seen as a path, a journey through a conceptual space of ideas. To make this tangible, let's lay down a coordinate system. This grid represents that space. In this space, every word is a point, a specific location. Words with similar meanings might cluster together. A sentence then is simply a trajectory connecting these points. As we trace the path the cat sat on we arrive at a fundamental question. What is the next point on this path? Where do we go from here? A language model doesn't give a single certain answer. Instead, it provides a probability for every possible next word. We can visualize this as a field of possibilities, where the brightness of a region corresponds to the likelihood of the path continuing there. The model indicates a high probability format, a slightly lower but still plausible probability for rug, and a very low probability for a word like moon, which doesn't fit the pattern. So, at its heart, a large language model is a machine that has learned the geometry of language. It has learned which words are close to others and which paths are the most likely to be traveled. So how does a model learn this geometry? The process begins with a simple game. We give the model an incomplete sentence like "the cat sat on the," and we ask our untrained model to make a guess. We can think of all possible next words as points in a prediction space. The correct answer, Matt, sits at a specific point in this space. The model, being untrained, makes a guess that's somewhere else entirely. The difference between the guess and the correct answer can be thought of as an error vector. The core of training is to calculate this error and use it to give the model a small nudge in the right direction. With this nudge, the model's internal parameters are adjusted, so its next guess will be slightly better. This process of nudging billions of internal parameters is what we call training. We can visualize this as a journey. Imagine a vast landscape where the height at any point represents the model's error or loss. The goal of training is to find the lowest point. Our model starts at some random high error point on this surface. With each nudge, it takes a small step downhill, following the slope of the landscape. Through millions of these corrective steps, the model gradually descends, navigating the complex terrain of the error surface, until it settles at a point of very low error, a place where its predictions are consistently accurate. By finding this minimum, the model has effectively learned the rich, complex patterns of human language. But what is happening inside the model during this process? What does it mean to learn patterns? It helps to think of the network as a massive committee of neurons arranged in layers. First, the input words are converted into vectors, unique numerical fingerprints for each word. These vectors are then fed into the input layer of our network. As the information flows to the next layer, the neurons here might learn to detect very simple, foundational patterns like common word pairs. The next layer receives this information and builds upon it, learning more complex structures like grammar and syntax. Deeper still, the layers begin to grasp abstract concepts and the relationships between ideas. Finally, the fully processed information reaches the output layer, which makes the prediction. It doesn't just output one word, but a probability distribution over all possible words, with Matt having the highest likelihood. And here's the kicker. While we know the overall structure, the exact function of these hidden middle layers is often a mystery. We can see the input and the output, but the internal reasoning is so complex that it's effectively a black box. Understanding what these models have learned is detective work of the highest order. So what makes a language model large? First, it's the sheer number of parameters, the internal dials the model can tune. If we represent each parameter as a single point, we can see how quickly the numbers grow. From 1 to 4 to 16, 64, the complexity expands exponentially. Modern models have these dials numbering in the hundreds of billions or even trillions, allowing them to capture an incredible amount of nuance. But all those parameters are useless without the second key ingredient, a massive amount of data to learn from. The model effectively reads a significant portion of the internet. It learns from vast libraries of books, from the endless text on websites, and from millions of lines of computer code, absorbing the structure and patterns of each. These two components, the model's size or number of parameters, and the scale of its training data, are symbiotically linked. Together, they are what give these models their incredible power. And what abilities they have. They can translate languages, write computer code, and even explain complex scientific concepts. This power allows them to act as translators, as programmers, and as tutors. This brings us to a profound and perhaps uncomfortable question. What is the difference between truly understanding something and being able to perfectly mimic the patterns of understanding? Because the limitations of these models are just as fascinating as their capabilities. First, they can hallucinate facts. A model might generate a statement that sounds perfectly plausible, but is completely nonsensical because it is just generating patterns, not retrieving verified information. Second, because they learn only from text, they have no physical intuition. If you ask one a simple question about stacking physical objects, it might suggest a configuration that defies the laws of gravity, leading to an inevitable and predictable collapse. But here is the thought that should give us all pause and a sense of profound excitement. These limitations, as clear as they are today, are rapidly disappearing. With every new architectural innovation, with every order of magnitude we add to their scale, the line between mimicking understanding and a form of genuine, albeit alien, intelligence becomes ever more blurry.